Yesterday, when Chris Palma was here, I joked that all scientific projects need to have a catchy acronym, and we have quite a few good ones in meteorology. For example, in recent years, I've talked about vortex and owls. And right now, some Penn Staters are taking part in a field campaign called PECAN, which stands for Planes Elevated Convection at Night. And I know there are alternate pronunciations of that word, but that's the one that's most popular in Pennsylvania. Let's break the acronym down. The home base is Hays, Kansas, the area of interest from northern Oklahoma to southern Nebraska. So this is truly a plains project. Convection means thunderstorms, but in this case, not the ones that form during the day, but rather at night means the project only targets convective clusters that form and strengthen in the evening or after dark, when they are especially difficult to forecast. These mesoscale convective systems, or MCSs, can be the size of a state or even larger, are responsible for at least 40% of the warm season rain in this part of the country, and also produce their share of severe weather and flooding. To get a sense for how common they are, here's statistics from the summer of 2011. The colors represent the number of times an area experienced an MCS between 6 p.m. and 6 a.m. local time, so evening and overnight. Yellow is about 20, red about 30. Considering there's only about 90 days in summer, these nighttime thunderstorm clusters happen a lot more than you might expect. Now, how about the E for elevated? Typically during the day, thunderstorms feed off warmth near the ground. So a plot of temperature versus height in the lowest few thousand feet would show the hottest air just above the surface, then cooling off with height. If temperature decreases fast enough, we'd use the term instability here. But once the sun sets, the layer of air closest to the ground cools, which is not favorable for thunderstorms. Any leftover instability is well above the surface, or elevated. PECAN scientists are especially interested in how this elevated instability gets its warmth and moisture. Usually it's through a fast-moving river of air a few thousand feet above the ground called the nocturnal low-level jet that's speediest in the wee hours of the morning. This field experiment features a unique armada of instruments, including 2 vehicles decked out with weather gear, several ground-based instruments that can measure temperature, humidity, and wind up through the atmosphere every 5 minutes, 2 mobile balloon launchers, 8 mobile Doppler radars, and 3 research aircraft, including a Hurricane Hunter plane. Participants in the PECAN project represent 8 research labs and 14 universities and include recent Penn State graduate Jake DeFlitch, who's working with the Center for Severe Weather Research.
I primarily work with the Doppler on wheels and the mobile mesonets. In the mobile mesonets, or the scouts, which we call them, we drive, deploy pods, and transect thunderstorms, collecting data throughout the way.
Because this project is focused at night, fatigue is a real safety issue, but the chief scientists have taken the necessary precautions.
Including at least 2 drivers in each car, including the Doppler on wheels and the mobile mesonets, in case the initial driver does get tired from driving throughout the day. The other one can then take driving overnight.
The PECAN project runs through the middle of July. Fred is back next with the extended forecast.